Hello, and welcome to this lesson on balancing redox reactions. In this lesson, I will first cover how to balance half reactions, and then using that knowledge, I'll teach you how to balance redox reactions. Third, I'll show you an example of balancing a redox reaction in acidic solution, and finally, an example of balancing a redox reaction in basic solution. To balance a half reaction, there are multiple steps you need to follow in order. First, balance all of the major atoms. Major atoms are any atoms besides for oxygen and hydrogen. Second, balance the oxygen atoms by adding H2O molecules to the side of the reaction with less oxygen atoms. Third, balance the hydrogen atoms by adding H+ atoms to the side with less hydrogen atoms. Fourth, balance the overall charge of the reaction by adding electrons. The fifth step only applies to basic solutions. Cancel out any of the H+ ions by using the reaction H2O forms H+ plus OH-. A helpful acronym can be used to help remember the order of steps. Major hydroxide, or major OH-. Here's an example of how to balance a half reaction. Take the following half reaction. Mn2+ forms MnO2. First, balance all of the major atoms. In this case, all the major atoms are already balanced. Second, balance the oxygen by adding H2O molecules to the side of the reaction with less atoms. In this case, we added 2 H2O to the reactant side. Third, balance the hydrogen atoms by adding H+ atoms to the side with less hydrogen atoms. Here, we added 4 hydrogen atoms to the product side. Then, the fourth step is to balance the charge of the reaction by adding electrons. In this case, we added 2 electrons to the product side to balance the overall reaction. Both sides of the reaction now have a charge of +2, and all of the atoms have been balanced. If this reaction occurred in basic solution, we would continue to the fifth step. We would cancel out any H+ ions by using the reaction H2O forms H+ plus OH-. The half reaction in acidic solution is Mn2+ plus 2H2O forms MnO2 plus 4H plus 2 electrons. The half reaction in basic solution would be Mn2+ plus 4OH- form MnO2 plus 2H2O plus 2 electrons. With the knowledge of how to balance half reactions, we can move on to balancing redox reactions. To balance a redox reaction equation, we need to split the equation into 2 half reactions. Then, we need to balance both half reactions separately. Third, we need to multiply the half reactions by whole numbers so that the total number of electrons lost is equal to the total number of electrons gained. Then, we add the 2 half reactions together to cancel out the electrons and any other molecules found on both sides of the reaction. If the redox reaction occurs in a basic solution, we need to continue to the fifth step and cancel out any H+ ions by using the equation H2O forms H+ plus OH-. Now, I'll go through an example of how to balance a redox equation in acidic solution. We are given the following redox reaction equation. MnO4- plus Zn form Mn2+ plus Zn2+. We are told to balance this redox equation. The first thing we need to do is split the redox equation into 2 half reactions. For this redox reaction, the 2 half reactions are MnO4- forms Mn2+, and Zn forms Zn2+. We need to balance both of these half reactions. Balancing MnO4- plus Mn2+. First, we need to balance all the major atoms. As you can see, all the major atoms are already balanced, so we move on to the next step of balancing the oxygen. To balance the oxygen, we add 4 H2O to the product side of the reaction. Then, to balance the hydrogen, we add 8 hydrogen to the reactant side of the reaction. Then, to balance the overall charge of the reaction, we add 5 electrons to the reactant side. Then, moving on to balancing Zn forms Zn2+. Zn forms Zn2+, has all the major atoms balanced, and it has no oxygen or hydrogen atoms, so we move straight to balancing the overall charge of the reaction. We add 2 electrons to the product side of the reaction to balance the reaction. We then want to add the two equations together and cancel out all the electrons. So we multiply MnO4- plus 8H plus 5 electrons form Nn2 plus 4H2O by 2, and we multiply Zn forms Zn2 plus 2 electrons by 5, and then add the half reactions together. Adding the two half reactions together gives us the balanced redox reaction of 2 MnO4- plus 5Zn plus 16H form 2 Mn2 plus 8H2O plus 5Zn2 . Now I'll go over an example of balancing a redox reaction in basic solution. We're given the following redox reaction. Br2 forms Br- plus BrO3- in basic solution, and we're told to balance the equation. First, we need to split the redox equation into two half reactions. This particular redox reaction is a special reaction known as a disproportionation reaction. In a disproportionation reaction, the same species acts as the oxidizing agent and the reducing agent, Br2 in this case. For this redox equation, the two half reactions are Br2 forms Br- and Br2 forms BrO3-. We need to balance both of these half reactions. We'll start by balancing Br2 forms BrO3-. The first step is to balance the major atoms, so we increase the molecules of BrO3- from 1 to 2. Next, we need to balance the oxygen, so we add 6 H2O molecules to the reactant side of the equation. Next, we need to balance the hydrogen, so we add 12 hydrogen atoms to the product side of the reaction. And finally, we need to balance the electrons, so we add 10 electrons to the product side of the reaction. Next, we'll balance Br2 forms Br-. First, we need to balance the major atoms, so we increase the number of molecules of Br- from 1 to 2. Second, we can see that oxygen and hydrogen are already balanced in this equation, so we skip straight to balancing the charge of the overall equation by adding electrons. We add 2 electrons to the reactant side of the equation, and the equation is balanced. Now, before we add the two half reactions together, we will multiply Br2 plus 6H2O form 2 BrO3- plus 12 hydrogen plus 10 electrons by 1, and multiply Br2 plus 2 electrons form 2 Br- by 5, and then add them together. Doing this, we cancel out all the electrons, and we're given the equation 6Br2 plus 6H2O form 2 BrO3- plus 12 hydrogen plus 10 Br-. Dividing this equation by 2, we're given the balanced equation 3Br2 plus 3H2O form BrO3- plus 6 hydrogen plus 5 Br-. The current equation we have is balanced for acidic solution, but the question specified that it's in basic solution. So now we need to use the equation H2O forms H plus OH- to cancel out the H plus ions. Doing so, we're left with the balanced equation of 3Br2 plus 6OH- form 5Br- plus BrO3- plus 3H2O. And that is the balanced redox reaction equation for basic solution. That concludes my lesson on balancing redox reactions. Thanks for watching.